The story of America's most advanced high-speed train begins long before its first journey on the tracks. It begins with a question that echoed across the United States for years: why can't America, the world's largest economy and technological superpower, have a high-speed train system like Japan, France, or China? For decades, millions of Americans traveled by air and road, watching other countries build futuristic rails while their own system struggled with delays, aging infrastructure, and outdated equipment. But that question, that collective demand for something new, something bold, something worthy of the modern age, finally pushed the country into a new era. And from that desire emerged a machine that would redefine American rail transport forever: the Amtrak Next-Generation Acela Express. When engineers and designers first gathered to describe what the new Acela needed to be, they didn't want just another train. They wanted a symbol. They wanted something that could stand next to the Shinkansen of Japan, the TGV of France, the Fuxing bullet trains of China, and prove that the United States was ready to reclaim its place in the future of rail. The original Acela, launched in 2000, had served well, but it was never truly high-speed by global standards. It was limited, constrained by old tracks, narrow curves, and aging corridors. The new Acela had to be different: faster, smarter, sleeker, safer, quieter, more efficient, and more iconic. And so the journey began. Amtrak partnered with Alstom, one of the world's leading high-speed rail manufacturers, known for building advanced trains across Europe and Asia. The project required not just building a train, but building an entirely new experience of travel. Engineers started with the body design, choosing an aerodynamic shape that cut through air with minimal resistance. Every inch of the train was sculpted with purpose. The nose was extended and curved, allowing high speeds with reduced drag. The body was constructed using lightweight yet extremely strong materials, enabling stability even at top speeds approaching 150 miles per hour. Inside the factory, workers assembled massive sections of the train with robotic precision. Each wheel, each motor, each bogie was tested repeatedly to endure years of high-pressure use. The motors were redesigned for quieter acceleration, giving passengers a smooth ride that felt almost like floating. The braking system was crafted with advanced safety controls, ensuring that even at high speeds the train could stop with absolute confidence. But even more impressive was the computer brain of the train: a digital control network that monitored everything from speed to temperature to wheel health in real time. This level of automation meant fewer delays, fewer maintenance problems, and a more reliable service for millions of travelers. While the exterior was being perfected, another team focused on what passengers would feel once they stepped inside the new Acela. They understood that modern travelers expect more than just transportation. They expect comfort, silence, space, power outlets, mood lighting, Wi-Fi, privacy, and a sense that the train is built for the future. The seats were redesigned to mimic luxury aviation, with wide cushions, adjustable headrests, ergonomic angles, and smooth recline mechanisms. The aisles were widened. Overhead luggage racks were engineered with soft close technology. LED lighting was installed throughout the cabins, adjustable dynamically depending on time of day. In the quiet car, sound dampening panels and insulation were upgraded to dramatically reduce noise. In the business and first-class sections, passengers would find not only comfort but luxury leather finishes, personal reading lamps, digital displays, touchless controls, and seamless Wi-Fi strong enough to handle streaming, meetings, and heavy work. Even the restrooms were redesigned with modern materials, soft lighting, and touch-free technology. The entire interior gave off an atmosphere of calm and efficiency, something rarely associated with old American trains. But the next generation Acela was not only about comfort, it was also about speed. High speed. Real high speed by American standards. With state-of-the-art tilting technology built into its cars, the train could lean naturally into curves, allowing higher speeds on existing tracks without compromising safety or passenger stability. This was revolutionary for the Northeast Corridor, a route filled with tight turns and old landscapes that historically prevented true high-speed travel. The tilt meant the train could glide through these curves without slowing down drastically, shaving precious minutes off every trip. Combined with more powerful motors and better traction systems, the new Acela could accelerate faster, maintain higher speeds longer, and offer the fastest rail journeys in U.S. history. Yet speed alone wasn't enough. America needed reliability. For decades, passengers complained that trains were late, outdated, uncomfortable, or too slow. The new Acela had to break that cycle. Amtrak responded by launching massive modernization projects along the Northeast. Rail yards were upgraded, maintenance facilities were rebuilt, stations were redesigned, and digital systems were installed across the network. Trains could now be checked, serviced, and repaired with unprecedented efficiency. Computer diagnostics allowed technicians to identify issues before they became problems. The entire ecosystem of high-speed travel was rebuilt around the next-gen Acela. Once the first full train set was tested on the tracks, a new chapter began. Engineers watched closely as the train accelerated, its motors humming with clean electricity. The ride was smoother than any American rail engineer had ever seen. There was almost no vibration. The cabin remained quiet even as the train approached high speeds. In test after test, the train performed flawlessly. It braked safely, it handled curves effortlessly, it maintained speed through long stretches, and every onboard system operated as intended. Passengers invited during trial runs described the experience as shockingly smooth, modern, finally something America can be proud of, and like flying on rails. When Amtrak finally announced that the next generation Acela would enter service, the reaction across the country was electric. Media outlets covered the story with excitement. America was finally entering the high-speed rail era. Although the United States still lagged behind nations like Japan and China in network size, this first step represented something symbolic: a commitment to transportation innovation. Politicians, engineers, commuters, environmentalists, and rail enthusiasts all understood the importance of this moment. It wasn't just a new train. It was a new identity for American rail travel. The arrival of the new Acela also sparked a larger conversation across the United States. People began asking bigger questions. If America can build this, why not more? Why not high-speed routes connecting Chicago to New York, Los Angeles to San Francisco, or Texas cities in one sweeping network? Why not invest in rail the same way America invested in highways or aviation? With every successful journey of the new Acela, public support for more high-speed rail grew stronger. Younger generations, especially, saw trains not as old technology but as clean, fast, efficient solutions for the future. The environment also stands to benefit. The new Acela, powered by electricity and designed with energy efficiency in mind, produces far less pollution than cars or airplanes. Every rider who chooses the train over a plane reduces carbon emissions significantly. With America's growing need to address climate challenges, high-speed rail became not just a convenience but a responsibility. Cities along the Northeast Corridor began planning station improvements, transit connections, and development projects around the new system, seeing the train as an engine of economic growth. As the train entered full service, passengers immediately noticed the difference. Boarding felt smoother, faster, more organized. The digital screens guided them to their seats. The moment the train began moving, they felt an almost airplane-like lift, a sense of forward force delivered with elegance. The large windows offered panoramic views of the American East Coast cities, forests, rivers, and coastlines flowing past effortlessly. Business professionals opened laptops, connected to Wi-Fi, and began working without interruption. Tourists took photos of the futuristic interior. Even daily commuters felt proud, riding in a machine that symbolized progress. The next-gen Acela quickly became an icon, a symbol of what America could achieve when it decided to invest boldly. Its silver and blue body streaking through the Northeast became an image of the future finally arriving. Newspapers and social media flooded with photos, videos, and reactions. Comparisons were drawn between the new Acela and high-speed trains around the world, and for the first time in decades, Americans felt they had something competitive. The story of America's best modern train is not just the story of steel, electricity, and engineering. It is the story of a country rediscovering ambition. For years, people said high-speed rail was impossible in America, too expensive, too slow, too political, too difficult. But the next-generation Acela proved that the impossible could become possible. It proved that even in a nation dominated by highways and airplanes, trains could shine again. This train is not the final chapter. It is the opening chapter of a new era. America now stands at a crossroads. With the success of the next-gen Acela, discussions of new high-speed routes in California, Texas, Florida, the Midwest, and the Pacific Northwest are gaining momentum. Billions of dollars